I got cut off on my last video. Okay, let's pick it up with equivalent statements here. So we're saying equivalent statements are two statements that they're both true or they're both false. So they have the same truth value. Okay, and we'll look more at this in class together. We haven't looked at a lot of specific examples yet with their truth values, but just know for right now that a conditional statement and its contrapositive are always logically equivalent statements. So the contrapositive was that weird one where you apply both things. You switch them and you negate them. So if your original conditional statement is true, that contrapositive is always going to be true also. If conditional statement's false, contrapositive is going to be false. Okay. Other two that are always logically equivalent statements are the converse and the inverse. So let's write that down here. Finish up our foldable. So the converse and inverse of any conditional statement are equivalent statements as well. So if the converse is true, the inverse is going to be true, and vice versa. If converse is false, inverse is always going to be false. Awesome. Let's actually take a look at an example. I do want you to write this example in your notes here. I'm doing two of them, so write conditional and then put both of these conditionals here, and we'll talk about both of them. So we got like kind of a real life one and then a more mathematical type of example. Let's look at this purple one I got right here. It says, if it flies, then it's a bird. Okay, I want you to, if you can pause this, I want you to try to write the converse either by looking at your notes, but try to do that on your own. Write the converse of that statement. I'll go ahead and show you. Converse would switch P and Q and would become this. If it's a bird, then it flies. All right, I want you to try to also write the inverse of that statement. So we're still looking at this one. If it flies, then it's a bird. Now the inverse doesn't switch anything, it just negates everything. So this would become, if it does not fly, then it is not a bird. All right, go ahead and practice writing your contrapositive here. So contrapositive is going to basically combine your converse and your inverse. So this one would become, if it is not a bird, then it does not fly. I want you to try to do the same with this second example I have here. I guess is that blue? Oh, they look so close in color. Go ahead and try to write that one all different ways. You can pause this and then play it and check all your work, converse, inverse, and contrapositive. Okay, so I'm revealing all of these here. Here's the converse. Here's the inverse. Here's the contrapositive. I think you can see the contrapositive. If you can't, I'm not sure if that got cut off at the bottom. Hopefully you can see that. It says, if it is not a quadrilateral, then it does not have four sides. So check yourselves there. Hopefully you got all those. Okay, let's look at this real quick. One other thing I want you to add to your notes, a word called a biconditional. Now, if you have a conditional statement that's true and the converse is also true, this is a very special scenario here. We call this a biconditional statement. So let's look at just our mathematical one we have here. So our conditional says, if it has four sides, then it is a quadrilateral. So think to yourself, is that true or false? If it has four sides, then it is a quadrilateral. Well, that is true. That's the definition of a quadrilateral. Okay, now I want you to look at its converse. If it is a quadrilateral, then it has four sides. That's also true. So if you have a case like this where the conditional and the converse are both true, then you have what we call a biconditional. And there's a special way you can write these, and it looks really weird. I'll show you. Looks like this. You see this? Yeah, that's actually something they do in math. I learned this in college. It's a capital IFF, and it just stands for some reason, it stands for if and only if. Okay, what that means, if you ever see IFF or if and only if, that means this statement works both directions. The original statement's true and the converse is true. Okay, that doesn't happen all the time, But when it does, it's very special. It's called a biconditional. So we could actually make this statement be, it has 4 sides if and only if it is a quadrilateral. Okay, we'll go ahead and stop it there and we'll cover this in class.